Hello and welcome, everybody. It's great to see that we have such a filled room. I know that it's the end of the day, so I'll try to excite you, but one thing I'm sure of, you're not going to be bored by a lot of company and corporate talks, and I'm going to show you a lot of seal faces, so this is going to be great anyhow. So short, brief introduction of me, myself. I studied computer science. I set up a data science department. This is where I noticed that studying computer science and data science doesn't make you a data scientist. You need to learn this in practice. Also doing it in research, same holds there. Research data is often very clean compared to like real data that you find in company databases. That's not quite the case. And this is something that I noticed when I set up a data science department at Wolfpack, where I actually had to work with online systems that have been years and years old. And this is where I noticed like, hey, I can't do data science at all. I first need to learn this on the job. And when I got new people into my department, these people didn't have a computer science background, and it was even more difficult to learn them how to do AI on the job. And this is when I started discussing with Buster over here, my co-founder, like, hey, how can we solve this problem? How can we teach people how to apply AI in the real world? And this is where we came to build Fruitpunch. So I'm the CTO of Fruitpunch AI, and we are a global AI for good community that aims to educate and apply AI for good. And our main way of doing so are our AI for good challenges. So what we do with these AI for good challenges, we search for organizations worldwide that have a data set and a problem that works towards the sustainable development goals. Once we find this, we put it into a nice little package, which we call an AI for Good challenge. And then we use this to have people learn on the job. So we make this into a 10-week project and have them execute AI. This way we track all their skills, so we know in detail about their computer vision, machine learning, soft skills, hard skills. And this we then use to work towards their ideal job goal, for example, MLOps engineer. So this is how such a challenge looks. We have a bit of preparation, of course. We recruit people on this challenge. We recruit real-world experts. We find people to give masterclasses on the topics, both on the domain topics as on the AI that we're going to work with. And then in only 10 weeks, we're going to go from dirty data to an implemented product. This with a group of 20 to 50 people. So you must be wondering at this point, how do these challenges look? Well, I'm going to tell you today about a couple of our challenges, but I'm going to do a deep dive in one of our cutest challenges ever. We scale all this through our platform. So we have a platform. I invite you all to make an account, of course, app.fruitpunch.ai. We have over 4,000 AI engineers there, which are part of our community and are part of creating our content. So it's not only us that creates our educational content, this is also community-driven. We have chapters all around the world where they give education under our flag. And we do these challenges with partners like WWF, a lot of universities, American, Dutch universities. As mentioned before, it doesn't really matter what type the organization is as long as they have data and the problem works towards good. So just to give you a couple of examples of the challenges that we've been doing, we've worked together with JZM Metabolic to estimate the amount of carbon that an organization consumes. So what you can imagine that every organization pays a lot of invoices. And every invoice has a small line that says, hey, this is what you bought. This line can be in Italian. It's often only 3 or 4 words long, so it's very hard to estimate what is in this line. But it does represent the consumption of the organization. If you combine all the invoices that an organization pays, what you get then is roughly the consumption. If you know what these products are, then you could connect that to a carbon footprint of each product, and then you know the entire carbon footprint. These challenges we only were able to do recently, since this is where large language models are essential. You're almost unable, if you just want to translate a line of an invoice, you go to the Google Translate API, and then you try to guess what this product is, you'll never figure that out. But using LLMs, we were able to build a very structured pipeline where each line goes through one of these models. We invited the model to give back a very structured JSON that both had the original language, the English translated language, a short summary of the product, and the different categories that it was in. This was able to do very accurately, and using this, we can now automatically, based on connecting this application to an CRP product of an organization, we are able to immediately estimate their carbon impact. Other project that we've been working on together with ESA is forest fire detection. Well, they basically said like, hey, we have the Sentinel range of satellites. I don't know if you're familiar, but ESA has, I think, 7 different satellite constellations, which a lot of them exist from multiple satellites, and they measure various things. Some measure near infrared, far infrared, full hyperspectral spectrum, radio waves. And they said to us like, hey, here you have all this Sentinel data, it's available online, you solve the world's problems. So that's what we did. We asked our engineers like, hey, come up with creative ideas, what we can do with this hyperspectral data. So we looked at flooding rivers, but also drying rivers, coral bleaching, forest fires, deforestation, all these things that you can do with this type of data. Working with hyperspectral data, not easy, and this is why for these types of challenges we then also get ESA scientists to do a masterclass just before the challenge. Then predicting floods. This was actually a very successful challenge. We did this together with a French organization. And there in France, flooding is a serious problem. That the river starts flooding somewhere and then in the end you get catastrophe. So they had sensors all along these rivers and wanted to predict how high the water was. Honestly, when they told me about this project, I was like, nah, maybe we'll be able to do that accurately by like 2 to 3 hours beforehand, right? So we'll be able to accurately predict the water level 2 to 3 hours up front. But we were able to do this by 6 to 12. So by measuring the water upstream, we were able to estimate the water level 6 to 12 hours in advance. And the nice thing about these types of projects is you learn so much because everybody always tries to grab the newest and fanciest thing. What you're doing here is forecasting. The same thing as if you want to forecast the amount of people that visit your website or the amount of sales that you're going to make in the next sales cycle. Often people try to run like neural networks, recurrent neural networks, and all these types of things. All this stuff is solved in the end with simple statistics. It's based on ARIMA and profit models, which are all based on classic statistics. For forecasting, this is still one of the most advanced methods out there. And that's also something that you'll learn by doing these types of challenges is, hey, throwing a neural network and a lot of compute at this problem doesn't always solve my issue, right? We also do a lot on healthcare. We have a specialized unit in that even. One of those is learning based on EEG signals about the health of people. And then it's really about predicting deterioration. Are people going to go to the emergency, going to need to go to the emergency room? Another is sepsis detection in children, which is the #1 cause of death in the Netherlands for newborn infants. So based on their blood levels, we can early detect whether they are likely to get a sepsis infection, and then they can antibiotics before the bacteria takes hold. AI for oil spills, we're actually soon going to start a new iteration of this. We both looked at sea spills. These are the ones that you see in the news. But harbor spills are a very serious problem of the Rijkswaterstaat, the Dutch water governmental organization. And what they want to detect is how much oil is there so that they can send in the right help. So we, together with a labeling party, first looked at, okay, what is this data? Can we segment it? Can we segment the different colorations? And by also segmenting the different colorations, we were not just able to detect the amount of surface oil, but also the depth, and with that the total volume. And this they can then use to send in the right teams to clean up the oil as quick as possible before it spreads into the climate. Furthermore, we also do more industrial new energy cases. AI for wind energy is one of my favorites in that case. I don't know if Hans is in the room. I know he was here today. Together with his company, Taruka, we looked at wind blades and how to detect damage based on the vibrations of the blades. They use a very special type of light sensor for this. And then you might think like, hey, there are a lot of vibrational sensors. Why use light detectors? Well, this allows them to build a full photonic circuit. And why would you want a photonic circuit? Because lightning strikes, right? These blades get hit by lightning all the time. If you put in an electric circuit in there, it will be fried every time lightning hits it. So this is when you need a photonic circuit. And together with them, we were able to build models that are able to predict where on the blade the damage is done, but also the depth and the severity of the damage, so that they can do predictive maintenance before the windmill gets destroyed. And lastly, in this category, we do a lot in the ecology space. Everybody likes cute animals, so do we. So together with Stanford, Cornell, NXP, this was one of the largest partner challenges that we ever did. We worked on the Elephant Listening Project. And this is a grid of 15 by 15 microphones that are over the Zambian forest. And there they listen for forest sounds. But the goal here is to detect whether they hear elephant rumbles and gunshots. So these we need to isolate, and this way they can track the movement of the population of the elephants, and of course also anti-poaching. So for here we are not only working towards, hey, find a model that is able to extract this piece of audio, that's relatively easy AI-wise, but we also work towards being able to do this on the edge. Since, as you can imagine, rainforests don't have cellular connections, so in some way you need to be able to do this on this device itself. And this is where you get a lot of constraints, right? You shouldn't use too much power. These devices are always battery supplied, meaning the more power that you use for computing the AI also means that the battery will drain more quickly. And therefore, you also don't have a lot of strong hardware. So building the biggest model that you can find there based on transformers and then say like, hey, I can detect this very accurately, yeah, that's super fine, but a microcontroller can't execute that, right? An execution round, one inference round will take 2 minutes. So that's why we completely optimize these neural networks as well to run on specific hardware of NXP, used its neural processing unit only when we were able to detect like basic sounds. Only then we got in the heavy neural networks that actually computed whether it was an elephant sound or a gunshot. And this is then able to be sent back directly to the rangers. And lastly, AI for seals. But I'm going to tell you all about AI for seals because we're going to do a tech deep dive. I told you I had cute photos of seals, so this is the first one for you guys. So AI for seals, what's happening? The problem, Hudson Bay. This is in northern Canada, and together with Colgate University, University in New York, they do a lot of ecology work there. And the reason that they go for seals is that is a keystone species. And a keystone species means that the species is very indicative of the health of the total ecosystem. So if there are a lot of seals, then the ecosystem is doing well. But if the seals population dwindle, then also the fish population and vegetation populations are dwindling. So then there's something wrong with the ecosystem. So you want to keep that track. You want to have at least yearly surveys and know how the seal population is doing. So how would you go about this? You go on a boat twice a year with a lot of researchers. You make photos for about 2 weeks of boating. Sounds really nice, but after those 2 weeks, you've made thousands and thousands of images. And then you get a couple of biologists that are able to recognize individual seals. And then you go sift through these photos. As you can imagine, this takes over half a year. You have these conservationists that can do very important work, that are trained biologists, that are just sifting through images of seals. Very cute, but I must say it must get annoying after a week at least. So yeah, this is a lot of manual work, and this is where we as an organization, as Fruitpunch, with our community can help out. So we wanted a non-invasive tracking method, which we can still do with these photos, but we want to get rid of this manual identification step. So let's do some AI for good. First, what is our approach? And this is something that every challenge starts with, a basic approach. How do we think that we can tackle this challenge? So first of all, it's face detection. We get raw images, these are just photos of seals, and then we need to be able to select the different seals that are in the picture, such that we don't have to run AIs over the full image, and we want to be able to count the different seals. So then we clip out the face and go for facial recognition or seal identification. Here we need algorithms that are able to make a ranking of the different seals that are likely the same seal when you get in a new picture. And lastly, we're talking biology researchers, right? These ecologists, they don't like running Python Jupyter notebooks, and they definitely have no clue what's going on when something breaks down. So you need an application where they are able to manage their data sets, where they can upload new images, and where they can do these seal identification in. And you must think right now, can you do that in 10 weeks? Well, sure we can. And this is what we did. So first of all, the detection. As all the AI nerds in here will know, object detection is one of the easiest things in AI these days. I would say that this is the most mature field that we have right now. There are so many tools out there to do object detection very accurately. It's one of the easiest tasks. So this is also where we started. If you're familiar with the matter, you'll know that YOLO is one of the most common things to use out there, but also RCNN and VIT, which is a transformer-based one, are very commonly used. And the nice things about these models, when I used to do neural networks, I had to build them myself by hand. I had to train them from scratch. And if I want to do something else, like for example, augmenting the images coming in, or I want to calculate metrics, I had to type like my own Python to do that, which is of course a waste of everybody's time. These things come with complete frameworks that allow you to train them for multiple different sizes. So you have smaller and larger networks. Yes, Marcus. I'm only 30, Marcus. Yeah, I've been doing this for quite some time now. But yeah, indeed. So, but right now, luckily, we have all these frameworks, things that would have costed us as a community weeks and weeks to build. We can now just click on top of these neural network frameworks. So a lot of the work is done for you. But then still you run into a lot of problems, right? No challenge that we do is easy and is as straightforward as throwing YOLO on it and then be done with it. Sadly, again, here that's not the case, because what do you do with these types of images? Right, the top one, is that a front-facing seal or a side-facing seal? I would say side-facing, and I guess that doesn't make too much sense to do identification because you're missing a lot of features. But the second one, is that a front-facing or side-facing one? And then this one, is this even a seal face? Should we count that? I don't know. Well, then we need to go back to these researchers and ask like, okay, and how would you go about this? So it's always a very iterative process. And in this case, we had to relabel the entire data set to make sure that the labels were consistent, because otherwise, well, you start to confuse the AI, right? But this we all figured out, and in the end we were able to build a very successful model. So we did 3 different approaches: RetinaNet, YOLO V8, and YOLO V5. I love that we use both, because I read a lot about these types of models, and I always think like, is YOLO V8 actually better? And it's quite hard actually to find decent comparisons. Well, here you have one. YOLO V8 does not always outperform YOLO V5, and the YOLO V5 framework is a bit better. So choose your pick next time that you need to do one of these projects. But it's mostly in terms of precision, in terms of MAP, which is the most relevant metric here that tells you something about the overlay of the bounding boxes. So this percentage is higher when the predictive bounding box is more overlapping with the original bounding box. Right, so in this case, YOLO V8 did significantly outperform YOLO V5, and this means that basically we got the 95% overlap on these images. So this part of the challenge solved. Clip out those faces, go to the next phase. Next phase is facial recognition. Now we need to identify seals. And where object detection is one of the most mature fields within computer vision, identification is actually very, very complicated. So what we want is a top 5 of the seals that are in there. And what you could do, the most basic thing that you could do, is build a classifier. And we also did this to build a baseline. So what you do then is you know that you have 100 seals of which you know the identity. You'll just build a classifier that's able to say like it's one of these 100 seals. Problem with that is, if you get a new seal on a photo, this neural network is already built with 100 outputs. And you can't just add one to the end of that. You need to retrain the entire, first add this one, and then retrain the entire network. This means that not only it's not usable for that, but it will also become very bad the more classes that you have in the end, right? The more classes that you have, the more confusion that a network can have. And this way you'll only be able to classify up to like 100, maybe 200 seals, but after that you won't be able to identify even more. Then you have clustering. This would be a way of saying like, okay, I'm going to group these images together and look which seals end up in clusters. But the more dimensionalities that you get, in this case, we have, I think these pictures are 480 by 480. That means that if you add all those dimensions together and try to cluster on that, this will also be computationally very heavy. And the last thing is coming up with some type of a similarity metric. And this is the go-to way for these things, but we try them all anyway, because you need to try all these different methods to see which ends up to be the best. As mentioned before, sometimes the old-fashioned methods work best for a specific use case. What we did was feature extraction and classification. I'm going to explain those in detail in a sec. Deep learning, classification, and cosine similarity. And we did metric learning, which is my favorite type of machine learning. Yes, I have that type of nerd. I have a favorite machine learning algorithm. So feature extraction, we use the HOG feature extractor. Those that have worked for a very long time in computer vision will recognize this because it has been invented in the 1970s or something. But it's a way to automatically extract features from an image. On that, we did a stochastic gradient descent optimizer to be able to end up with a classification, which was fairly accurate. As you can see on top, we got 95% accuracy. The problem here was adding more seals meant the whole data set started to work worse because in the end it relied on classification. And then deep learning, including a similarity metric. So this is a very common way of solving this problem. You take a deep learning classification model. You just rip one of the internet. You can use ResNet. You can use YOLO. You can do any of these algorithms. In this case, we used EfficientNet V2. And what you do is you take the trained network. You train it on all your seal data. And then you just cut off its head. And what the head of the neural network does is it says, this is seal 1, this is seal 2, this is seal 5, etc. But instead of keeping that layer in, you just completely cut it off. What that means is when you put a new photo in, at the end, you get an array of numbers that represents this seal, that represents the features of the seal. So what you've done is you've trained a feature extractor. Right? These numbers that are now at the end of our neural network, since we cut off the classification step, they now represent sealiness in some way. We have no clue what way, but it does. And we can then use those vectors, as we call them then, these embeddings of the seals, we use those to compare them together. And which sealiness looks the most like another sealiness? In this case, we use cosine similarity to compare the different vectors. This way we're able to in a way more robust way, detect new type of seals. Because in this way, we can both use the classification step for which the algorithm was trained, since those vectors will be very close together. But if we have a completely new seal, we will also see that this vector is completely different from all the other vectors that we had before. And in this way, we can add new seals to the data set. A lot more complex than just throwing YOLO on it, as you can see. What you can see here, by the way, that's also interesting to show. What you also want to check with these types of algorithms is what is my model actually looking at, right? I know this very famous example of a dog classification model that is able to detect huskies with 100% accuracy, but it never looked at the dog itself. For some reason, huskies are always photographed in the snow. So I was just able to see, oh, when I see a lot of white, then it must be a husky. You want to check for these types of things, and that's why you do a SHAP analysis. And this is a way of explainable AI. And then you look at, okay, where is the neural network actually looking? And here you see that it's mostly looking at the eye and the chin of the different seals, because that's where you have high activations in the activation map. These types of things are just cleanliness that you need to check with every AI project that you do. You want to make sure that, hey, my AI is actually looking at the good stuff. Here again, we got quite accurate. We went to 96% top 5 similarity. Top 5 similarity here means that in the top 5 it generated, the seal that was actually the right seal is in there. And the top 1 accuracy, meaning that the top is the actual seal that we're looking for, that accuracy was about 87%. So that's quite nice for an algorithm that's a lot more robust than the previous one. Lastly, metric learning, my favorite type of machine learning. What you do here is you you teach multiple neural networks at the same time to differentiate between classes. So what you do is, here you see it with precedence. You take 2 images of the true class and one of a false class. So that's a random image from one of the other classes that you're looking at. And what you then, with the triplet loss, what you then do is you punish the network when it makes the mistakes. So if it says like, hey, these 2 are the same and it's correct, then you reward it. But if it chooses the wrong one, then it punishes it. The difference between this and classification, it doesn't try to overfit on, hey, I try to predict a specific class. It builds up what you call a Euclidean space. So it builds up a network of how these pictures relate. So instead of identifying a specific class, it learns how images relate to one another. And in this way, you create a space which, again, you are then able to add new clusters of clusters to when new seals enter the game or are born in this case. The results, we didn't have enough data, sadly. Triplet and Siamese network are notoriously hard to train. This is mostly because they use 3 different neural networks at the same time. The same holds for training GANs. These are very, very prone for, how's it called, gradient explosion. So in this case, we just didn't have enough data. The networks kept on exploding. So we got some results. Like here you can see that it's actually quite, for this specific example, it was quite accurate. These are all the same seal indeed, but the bottom one, it completely screwed up. So sadly enough, if someone has a data set of identified seals somewhere, please give it to us, then we can give it another go. So hopefully we'll get there in the next iteration. And then last, of course, the application. Oh yeah, sure.
Can you, in the middle, use a generative step to create like alter egos of the same seal and enrich your data set with the same animal, just from different angles and whatever?
That is an interesting question. So what you're basically asking is, okay, you can do data augmentation. Of course, we did the basic data augmentation. Yeah, but then generating new data. The reason that it's often not done, because it's kind of dangerous and you can't check for it. And what I mean then is, I think it's commonly referred to these days as neural network collapse, of generative collapse. And that means that you train an AI on something that an AI produced. And you have no clue how these two differ. Right? You don't know that. And that can be in catastrophic ways. And then the mistake that the first neural network made will be made even stronger by the next steps on top of that. And it's almost impossible to check where that went wrong. So it's a very risky strategy. So it's a very interesting one, but for real life applications, I wouldn't per se recommend doing that. But then, the application, right? Biologists need to be able to use this. So there were a few requirements. They need to be able to upload images. They need to add some basic metadata, descriptive notes, of course, what's the name of the seals, that kind of stuff. You need to automatically detect all the faces in an image. It needs to be able to verify these automatically generated faces, aka the researcher needs to be able to check, hey, are these bounding boxes drawn correctly? And if not, they need to be able to correct them. They need to download additional movement data of the seals, and you want to be able to view different collections of data sets. So that's what we are now to do. This is the architecture that you use. I don't know if you have any software architects in-house, but I would say this is a very clean one for prototype application. So in the front end, it's a Next.js application where we then are able to show that in a web browser, which is, well, hyper common these days. The backend is a fast API backend. The machine learning endpoints, we made sure that those are separate endpoints. A very important reason to do this and just not build them directly into your backend is because often running machine learning algorithms has a lot of different requirements talking about the hardware, right? If you need to have that thing be very quick, you want to plug in some GPUs, but you don't want to plug in GPUs in your basic backend server because it won't use them at all, right? So you make those into different endpoints. And then we have a database. One is an S3 database that's just blob storage, hard drives where we can drop the image, and one is a PostgreSQL database. This all nicely Dockerized. I'm not going to go into details why this is a good idea, but it basically means that it's easy to launch for new researchers. So if you want to deploy this application somewhere else at a different university, this allows us to very easily do that. So that's the architecture, and this is the result. I was amazed that we got this far. Just in 10 weeks, we were actually able to build this application. So what you see here is a way to create data sets. You're able to robustly upload images. Sounds easy, uploading images to a backend, but if you're uploading thousands of high-res images, you run into a lot of problems with timeouts and latencies and all this kind of stuff. And this application corrects for all of those. I see a software engineer in the room. He's nodding. Yes, I know those problems. And you can leave the notes, etc. Here you then see the different collections of your database, of course, with cute seal faces on them. And there you can manage them. This is the automated detection. And then I also think that the software engineers in this room are like, how can you build all this in 10 weeks? Well, you don't. This is all stolen. This is just an open source labeling application that we incorporated inside the application. Never do other people's work twice if you don't have to, right? So the object detection and correcting application is completely open source, just directly integrated in our SealNet app. And then here we have the identification. So it's able to identify whether they are verified. Here means that a researcher can say, yes, this is indeed the correct prediction. This also is saved, of course, back to the backend, so that can be used for retraining the data set. And it gives a certainty score of how certain it is that it is this specific individual. So in the end, we were able to do face detection, just very accurately. As mentioned before, object detection, very easy. Face recognition, I'd say we can do better there. I think with more data, this is also a very evolving field. It's really state of the art in that sense. So I think we can move up a little. And then the application, as mentioned, I was very amazed. And this is also why we're looking for new data sets. And not only for seals, but this whole data set, while the application is called SealNet and it has an AI-generated cute seal logo, it is actually very agnostic from what problem you're trying to solve with a combination of object detection and identification. So we're looking into other pinnipeds. For the ecology nerds, that's the family of walruses and seals and sea lions. Cetaceans, so dolphins and whales, and also primates. So we're looking for other researchers that have data sets that want them identified, so that we can reuse the methods that we used on the seals and also expand on the applications such that it support all these different species. So if you know an ecologist that knows something about one of these species and has a data set, please hit us up. We're looking for more of these. So that's some conclusion of our AI for Seals project. And I know you're all now looking at me like, wow, Sako, that sounds super cool. I want to do that as well. You're very invited to, yes. So what we have now completely new off the bat is our AI hero journey. And here we invite engineers from companies to not only join into a challenge, but we also give them expert guidance. We look together with them at the learning goals. We make sure that they have the right position in the right challenge such that they meet those learning goals. And we have this in now a 12-week program where you're onboarded and then finish one of these challenges, get certified and get verified challenge-based skills. The next challenge that we're going to launch is AI for Turtles. Then you need to be really quick because we're launching that next week. But I'm sure that there are some people here enthusiastic enough to join in on that. Here we do exactly the same thing, but then with sea turtles. So they pluck them out of the sea, make pictures of them, and then drop them back in. And we're going to help these ecologists again to not have to sift through thousands of turtle faces. This one we just finished, sorry. Together with Greenpeace, we put a camera on the Tata Steel factories and automatically identified poisonous plumes, which they then can try to take down Tata Steel. That's up to them. And then AI for coral reefs. This challenge will launch in 5 weeks. And there you'll be able to work together with marine biologists to identify and segment different coral species based on surveys of the ocean floor. So make sure to join in. If you do, you get this beautifully new designed and implemented hero's journey in our platform that will be taken to onboarding, coaching, finishing the challenge and getting accredited. So I invite you all to at least make an account on our platform and join in our movement for good. That's it for all. That leaves me to wish you a very, very fruitful day. Any questions? Yes, gentleman over there. There's a microphone coming your way.
Hello, first of all, that was a really good presentation. I love your platform, and I didn't know that existed. I have a question about was it SealNet? SealNet, yeah. In your presentation, you said that you made your ML model endpoint available to your FAST API. My question is, what platform did you train and serve that to the FAST API? Just curious.
So for the training, we have several options. It depends on the challenge which one we use. Sometimes they get sponsored, for example, by AWS, and then we train everything in AWS, etc. In this case, we got HP in there. We have on-premise HP hardware, so the big computers. I don't know if you're a GPU nerd, but if I open the case, you have like 2 of these RTX 8000s in there. And this we use to train the models on, so that's used trained on on-prem machinery. The models themselves just run on a simple web server. So the inference in this case doesn't need GPUs, but you would be able, since it's all Dockerized, to push that to a GPU-enabled machine very easily.
Thank you.
Oh. Yes.
Hey, thanks for your talk. I really like the idea of the company, but what is your business model? How do you get money? Do you only rely on the partners that you have on each challenge, or?
No, so the challenge part of our business is non-profit. That means we do ask a basic fee to be able to cover the operational cost, but our business model is in corporate education. So we sell these things like the Hero's Journey to organizations that want to have their people guided throughout their learning journey and want to be certified for the different skills that they come up with. So in that case, we're an educational platform.
Yeah, cool, thanks.
So what's the next step? Get more seals?
Get more seals, get more primates, pinnipeds, other animals, turtles we already have, so don't bother about those. So that's the next step for the seals.
Because I've seen multiple hackathons where they did similar animal identification stuff, like I worked on one for whales and whale tails. But you purposely worked on this so more researchers can do that for their own cute animals.
Yeah, the goal is for the whole application that we build it in an abstract or a way that we are able to also add the whales in there. So we're indeed looking at dorsal fins and flukes and also other types of animals. So it's really an animal identification platform.
Have you seen any adopters yet?
This is the first iteration of such a challenge. So the turtle one will be the second. So not yet, hopefully soon after that one. We have open sourced the code, so you would be able to use it, but there are definitely some things still on the wish list there, right? So it's not that right now we push this towards ecologists. We would like to run, I think, at least 3 of these identification challenges to perfect the code before we also start pushing it to other researchers.
Well done.
Thank you. Yes?
What about the data sets? Like, are you open sourcing them?
As you can imagine, we don't own these data sets, so that depends a lot on the challenge owner. In this case, that's Cornell University. They haven't allowed us yet to publish this data. And for no reason that nobody knows, universities are very protective of these types of data sets. So where the researchers would love to share this with us and share this with everybody, I've been in a legal struggle with Cornell for, and I'm not kidding you, like 3/4 of a year only to obtain this data set. So yeah, it's a struggle. But sadly not been able to open source it yet. But if we can, we always do.
Cool.
Yes, gentleman in the back.
Hi, thank you for your presentation. I really liked it. I was wondering what the collaboration between the engineers during a challenge looks like. So you have 20 to 50, you said, and how do they collaborate, in what way?
Very good question. So as everybody knows, collaborating with 50 people at the same time is very hard up until impossible. So we cut them up in sub-teams. And that's actually the different approaches that I went through, right? We have the detection group, we have the recognition group. Of those we had 2, because we knew that there were a lot of different methods to try there. And we have an application team, a front-end and a back-end team. So in this way, we divide the challenge in groups with a maximum of 10 people in the same group. And then for collaboration, we basically leave that up to them, but we provide them with GitLab environments to publish the code, do web servers to test it on basic infrastructure in that sense. And we use the basics of a Scrum method in Notion to be able to track the progression. Any remaining questions?
Does that mean that you can say like I have a starter which is in the front end? Can you just say I want to train them in front end?
Yeah, definitely. Yeah, so that's the hero's journey part, right? If you want to train in something very specifically, we make sure that we find a challenge that's fitting for, and we have them, in this case, also with the experts, other experts that join in. If someone is a junior, we make sure there are other people in there and that they have a nice discussion about what different methods there are to tackle this problem. We also accreditate them specifically on the skills that they are training for.
Yeah, great presentation. So what would be the typical time commitment if, say, I was to sign up to the next project?
So typically we see 4 to 8 hours per week. So it's a 10-week long challenge, and this allows you to, well, be very clear about your time, right? Normally if you start a hobby project, I don't know about your hobby projects, but mine always take years and years and years, and they drop in popularity and they rise. Here you just have 10 weeks, we expect 4 to 8 hours, and then you're done. And of course, you're then very welcome to join in on to the next challenge.
Brilliant. Yeah, thanks. Yeah, all of my hobby projects are all sitting in GitHub unfinished. So
Yeah, no, I have the same thing. That's why I can structure these, right? Any remaining questions? Well, then I would like to thank all of you for your time and your attention, and have a very great weekend.